This is a training module for the Linear Technology LTC4263 Power Source Equipment Controller with Internal Switch. Welcome to the training module on LTC4263 PSE Controller with Internal Switch. This training module gives you an introduction to Power over Ethernet technology, PSE features, and application information. The LTC4263 is an autonomous single-channel PSE controller for use in IEEE 802.3af compliant Power over Ethernet systems. It includes an onboard power MOSFET, internal inrush limit, current limit, and short circuit control, IEEE 802.3af compliant power device detection, classification circuitry, and selectable AC or DC disconnect sensing. Onboard control algorithms provide complete IEEE 802.3af compliant operation without the need of a microcontroller. The LTC4263 simplifies PSE implementation, needing only a single 48-volt supply and a small number of passive support components. A PSE is required to provide a nominal 48 volts DC between either the signal pairs or the spare pairs. This device can see more application into network device equipment, which supports PoE. It can be used to power up the power devices in networks. The device connects to the single transformers that interface the PSE to the Ethernet cable. It performs detection and classification of the device at the opposite end of the cable. And if this device is a powered device, PD, then 48 volts is supplied to its front-end power supply. The front-end supply of the PD then outputs an isolated voltage for use by the main load. Programmable onboard power management circuitry permits multiple LTC4263s to allocate and share power in multi-port systems, allowing maximum utilization of the 48-volt power supply. Built-in foldback and thermal protection provide comprehensive fault protection. This page shows the block diagram of the PoE. The device that supplies power is called the Power Sourcing Equipment, PSE. A device that draws power from the wire is called a Powered Device, PD. A PSE is typically an Ethernet switch, router, hub, or other network switching equipment that is commonly found in the wiring closets. PDs can take many forms: digital IP telephones, wireless network access points, PDA or notebook computer docking systems, cell phone chargers, and HVAC thermostats are examples of devices that can draw power from the network. The LTC4263 autonomously tests for a valid PD connected to the port. It repeatedly queries the port every 580 milliseconds or every 3.2 seconds. The LTC4263 checks for the signature resistance by forcing two test currents on the port in sequence and measuring the resulting voltages. It then subtracts the two VI points to determine the resistive slope, while removing voltage offset caused by any series diodes or current offset caused by leakage at the port. The LTC4263 will typically accept any PD resistance between 17 k ohm and 29.7 k ohm as a valid PD. Values outside this range are reported to the user by a code flashed via the LED pin. The LTC4263 will classify a port immediately after a successful detection. It measures the PD classification signature current by applying 18 volts typically to the port and measuring the resulting current. The LTC4263 identifies the three IEEE power levels and stores the detected class internally for use by the power management circuitry. In addition, The LTC4263 allows selectable enforcement of IEEE classification power levels. The LTC4263 includes a power management feature allowing simple implementation of power management across multiple ports driven by a single power supply. The power management pins of all LTC4263 devices are tied together along with an RC network to prevent over-allocation of power in a multi-port system. The LTC4263 power management uses pulse width modulation to set the power requirements of each PD. Capacitor CPM is used as a low-pass filter to generate the average power requirement for all PDs in the system. Set CPM to 1 microfarad. The multiple LTC4263s implement power management. The power management pins are connected together and to an RC network connected to VSS. This page gives an overview of driving an LED from a 48 volts power supply. The LED is turned on when the port is connected to a PD and power is applied. One flash indicates low signature resistance, 2 flashes indicate high resistance, 5 flashes indicate an overload fault, and 9 flashes indicate that power management is preventing the port from turning on. The LTC4263 includes a feature for efficiently driving the LED from a 48 volt power supply without the wasted power caused by having to drop over 45 volts in a current limit resistor. The modulation frequency of the LED drive is 28 kHz, making the on period 2.2 microseconds. During the 2.2 microseconds that the LED pin is pulled low, current ramps up in the inductor, limited by our LED. Diode D2 completes the circuitry by allowing current to circulate while the lead pin is open circuit. This page gives you a brief introduction to application information like power control, port overload, mid-span backup, thermal protection, etc. Demonstration circuits 981A and 981B features the LTC4263 in single-port power over Ethernet power sourcing equipment, mid-span and endpoint solutions. DC981 provides 2 implementations of a PSE controlled by the LTC4263, a mid-span PSE, and an endpoint PSE. A single 48 volt supply is all that is required to power the board. This in turn provides power to the mid-span PSE and endpoint PSE outputs. On each solution, the LTC4263 provides detection of a PD, classification, power management, safe power on of the PD, port current limit, and disconnect detection. Here we show a typical application block for the LTC4263. The LTC4151-1 monitors the isolated 48 volt power supply to the LTC4263 single port power sourcing equipment controller. Communication across isolation through optocouplers to a microcontroller is simplified with the LTC4151-1's split bidirectional SDA line to separate data in and data out. Pull-up resistors tie directly to the 48 volt supply for pins SCL and SDAI, which are internally clamped to 6 volts. An inverted SDAO is configured to be clamped by an optocoupler diode. With the low-speed optocoupler shown, the LTC4263 generates its own 5 volt supply, and the LTC4151 high voltage protected I2C pins. A separate digital supply is not needed on the PoE side, just the single isolated 48 volt supply.